Right. Now, Ivy, hit the lights, please. I did have to reboot my computer. As soon as I did yesterday, the pen worked fine. Okay. So, given the functions g of x, f of x, and h of x shown below, the correct list of functions ordered from greatest to least by the average rate of change over the interval from 0 to 3. Now, we used to do a ton of these kind of questions early in the year, and I'm coming back to them because the Regents exam absolutely loves these questions. What's another name for rate of change? Slope. How do you figure out the slope? Come on, guys, how do you figure out slope?
mx plus.
No, that's the equation of a line.
Oh. Sorry.
It could be, you could do, yeah, and what's the formula for slope?
Next time. Maya's name is
Well, the shortest and easiest version. Go ahead. Change in y over change in x. Very good. Okay. That triangle, for what it's worth, is a shortened version of the Greek letter delta. Yeah, delta meaning difference. Delta D. Okay. G of x is x squared minus 2x. So the first thing I have to do is figure out g of 3 because it wants it over the interval of 0 to 3. So if I plug in a 3, I'm going to get 3 squared minus 2 times 3, which is 3. Then I'm going to plug in a 0. I love 0. 0 squared minus 2 times 0 is 0. And then the slope is 3 minus 0 over, the input was 3 also, 3 minus 0, which is 1. So g of x, the average rate of change is 1. This guy is so much easier, it's a table. What does the y's go up by? 6. And what do the x's go up by? If I do change in y over change in x, I get 6 over 3, which is 2. So far, the biggest one is g. And this guy here, from 0 to 3, this is the point 0,2. I like writing the point 0,2 because it reminds me of the table. 0 in the table is 0, 1. On the graph it's 0,2. And then 3, 3, 9. Here's my point 3, comma 9. So now I do my subtraction. 9 minus 2 over 3 minus 0, which is 7 over 3. Now, the exact value for 7 over 3 is 2 1/3 or 2.3 repeating. All I care is that it's bigger than 2. Because they just want them in order from, let's be careful here, greatest to least. So if I go from greatest to least, the greatest is H is the greatest, and then this guy is F, and this is like, I want to hit. I physically want to hit the person who made this question. Because instead of going FGH, which we have done our entire lives, what do? GFH. So what they're trying to do is they're trying to trip you up. Please let this be a lesson to you. The people who make these tests are evil. They're not testing to see how smart you are. They are trying to destroy your grade. I have no problem whatsoever with someone who makes difficult questions to try to trip you up. Who gives you difficult questions to test your knowledge. And I don't have a problem if you take a Regents exam and they put 1 or 2 of these kind of tricks on the Regents exam. Because you know what? 100 really is a truly special grade. And if you put 1 or 2 little tricks on this, like this, to stop a kid from getting 100, I call it a 100 buster. I'm okay with that. But there are kids who need this test to graduate high school. And can you imagine if a kid gets a 64? And it's because he doesn't realize it goes GFH instead of FGH, like everything else he does his whole life. And it's not just one question. The test is chock full of them. Look at the one you just read a minute ago. How many more? Not how many. How many more? You guys are strong students. Success in school kind of comes naturally to you. Think of kids who do not have success in school. Think of kids, if you will, who are coming here and their dominant language is not English. Do you think they're catching up on those tricks? Yet they can be just as good a math student as anybody else. And the problem is the people who make the test. So I really do have a problem with that. Like I said, 1 or 2 on a test is fair game. And I think you even know that as a student. the teachers are always gonna put one or two on there that are extra tricky. But to make so many questions tricky like this, it's evil. It's just, it destroys the purpose of what the test is supposed to show. The test is supposed to show your general understanding, awareness, and competence in the material. It's not supposed to test repeatedly your ability to decipher tricks and deviousness. Okay, so anyway, we're gonna go F first. F is the second, so H is the biggest, then F, then G. H, then F, then G. That's choice 4, right down there at the bottom, okay? Please, you don't have to raise your hand, but my question to you is, did anybody do it all right and screw up the order because they didn't see FGH? Or they thought it was FGH? That's the question that I would have. I know we did that exact question earlier this year, and I gave a little rant about how much I hate these people. So, okay. Today, or this particular question is about step functions. And we're going to do one question today about step functions, and on Thursday we're going to do a little bit with step functions. And I believe that's the last material that we have to do this year, all about step functions. Or, yeah, the last thing to cover for the year. Kids get a little bit confused. I would like to have written it like this, if I could, but I don't have such big squiggles, or whatever you want to call them, set notation symbols. First off, there are two questions here. One says f of -5, one says f of 5. Okay? Now, the next thing that I want you to do is take a look here and notice that it says the following. Now, I want to get rid of the squiggles so you can see a little bit better. It says there are two different rules. One rule says f of x is 2x squared. The other rule says f of x is equal to 3x minus 4. But here's the thing. You're going to use this rule if it's 2x squared, and we're going to use this rule, if the x is smaller than or equal to 2, and we're going to use this rule if the x is greater than 2. We have this drill we do every day in practice where we run the bases. And we have this one particular play called slow and behind go, in front no. And what it means is if you're on second base, if the ball is hit to this side of you, no, don't go. If the ball is hit to this side of you, the behind side, then go. So you have to see where the ball is hit. If it's hit slow or behind, go. If not, or if it's in front, no. So this is saying if the x is less than or equal to 2, go, or use this rule. And if the x is bigger than 2, no, or use this rule. So in this case, f is -5. Which rule should I use? The top rules. So I plug in a -5, and I get 2 times -5 squared. What's -5 squared? 25. And what's 2 times 25? 50. That's my answer. Okay. And now, we'll take a look at the next one. F of 5. Is f of 5 less than or equal to 2? No. So now I look at the next rule. Is it greater than 2? Yes. So I'm going to plug in a 5. What's 3 times 5? Minus 4. 11. And that's the answer. Okay. Again, we did that work earlier this year, but we didn't spend a ton of time on it. So I'm just kind of cleaning up little details before we begin actual Regents review. And as far as today's lesson goes, I've actually pretty much taught you how to do linear regressions already. So let's go back. This scatter plot here is the representation of this table here. And if I was to draw a line of best fit, remember, God bless, the line of best fit kind of goes through the middle here, and we want to have more or less the same number above and below. This has 3 below and 3 above, but one of them is practically on the line. Here's the thing. Do you remember, I think I mentioned yesterday, I know I mentioned it in the other class, I think I mentioned it in this class. Mary can draw a line of best fit, Emma can, Emily can, Maya can. They can all be a little bit different, and they can all be right, if they ask you to draw a line of best fit. All they're looking for is that the line goes through the middle of the points and has roughly the same number of points above and below, more or less. Your calculator is capable of calculating the best line of best fit for any linear function. And when you calculate the best line of best fit, it's called a linear regression or also known as the least squares line. And you don't really hear the bottom terminology very often. The top one is the one they always say. So let's get out your calculator and show you how easy this is. You already know how to do it. Go to Stat Edit, and we're going to use L1 and L2, that's list 1, list 2, and we're going to enter this data. Go ahead. Yeah. You're good with this, right? You know how to do linear regression? If not, wait 2 more minutes, and if you are, then you go now. Okay? Totally up to you. All right, so we enter all of this data. Now, once we enter this data, the next thing that we want you to do is go to Stat, Calc, and when you go to Stat Calc, it's going to do this. Yeah, then down to linear regression, and hit enter, and then enter again, and it'll say y equals ax plus b, and then it'll say a equals b equals. What did you get for a equals? All right, and usually they round to the nearest hundredth, so I'll go 52.71. And what did you get for b? What'd you get? 1513 point what?
94.
Okay, so that means in y equals, they write ax plus b, but we would think mx plus b. It's 52.71 plus 1513.94.
Wait, where's the X?
Oh, x plus 1513.94. Now, 52.71 is not, I repeat, it is not the slope. It's what we call the correlation coefficient. It's a measure of, well, let me backtrack off that. Think of it as a slope, 52.71, how much you're going up and over. And then the y-intercept would be about 1513, and that means that my line should have been a little bit better and gone down toward that. Okay, and if you notice, my line did have a little bend in it, so that would be the problem. All right, this is the linear regression. This is the line that you would come up with, and you would graph, and so on and so forth. Now, there is this other thing called a correlation coefficient. We'll talk a little bit more about that during review, but not at this particular moment because I don't want to confuse you. Any questions? Okay, in other words, this equation is the equation of that blue line. Are we clear?
Yes.
Okay. And we already did that, if you remember, when it came to writing functions. I drew the least squares line on the graph. Now the next one says something like, what would you expect the value to be for 30? All you have to do is plug a 30 in for x. X equals 30. So take that equation that we just wrote on the board and write down y equals, what was it, 52.71
Yeah.
times 30 plus 15 whatever. Okay. Now, what was the equation of that line again? Y equals
52.71
plus what?
times
1513? Point 54? 94? Okay. So this is what we're going to do. Listen. We are now going to discuss, are we all good on that line? We already did that like a week ago, a week and a half ago. Are we all good? We're comfortable with that?
Yes.
Right? Stat, edit, crunch the numbers. Now, that is the line of best fit. And it's important to realize how far off the line of best fit each point is. And that is what the residual says. Now here, these are actual values. Okay? These are actual values. let's do predicted values. So what you're going to do for the table here is you're going to plug in a 14, an 80, an 84, a 118, a 149, a 192, and you're going to crunch those numbers right there and put them all in that column. Do that now. Okay? In other words, this is the value on the graph. You plotted, or it plotted as a scatter plot, 14, 15, 10, 80, 61, 78, 84, 5912. Now, let's take each of these numbers here, these predicted values, and let's plug them one at a time in for x, because this is the x and this is the y. Plug them in, and then when you plug in the 14, what the formula says to 14, that's the predicted, according to the formula, value, write it in this space. Plug in an 80, write it in this space, 84 in this space, and so on, each of the ways down. I'll give you a minute or so to get that done, 2 minutes. You don't have to show work if you don't want to, just literally plug in 52.71 times 14 plus 1513.94, and then put in the value to the nearest whole number. Well, all of these values are nearest whole numbers, so we might as well do nearest whole number. That's fine, but from now on in, you can just use nearest whole number. I'm trying to make it a little easier on you, so Phoebe. It's so weird. I just looked at every kid's paper. Pardon me. Okay, so can someone tell me the top value here, the predicted value for 14? 2,251? 2. Okay, good. Now, what about for 80? 5731. What about for 84? Slow down. Let's do one at a time. Ivy. 5932? 42. Okay. So Phoebe, 118. Okay. Font, 149. You didn't get to it yet? Okay. Where else are we looking at here? Sammy. Mary. 9368. And do I have a second on 9368? Good. And Emma, what do we got for 192?
11,034.
Okay, 11,634. Okay, so here's the deal. What is a residual? Have you ever heard of the term residual just in the English language, not a mathematical specific thing?
I don't think so.
All right, well, here's a good example of a usage. It's a residual effect. Okay? For instance, a residual effect of the fact that you do your homework is that your grades will go up. A residual effect of lying will be distrust by others. Yeah, you may have gotten the thing you wanted to get, and you may have gotten away with something, but you have destroyed trust. And that's very much real. So a residual is the other things. Now in mathematics, the residual is the difference between the predicted score and the actual score. So if we were to do 1510 minus 262. In each case, I'm just going to subtract here. 1510 minus 2252. I am going to get what? 742 negative? I think that's what it is. Can you just check on your calculator real quick? Do 1510 minus 2252.
Yeah.
Good. On the next one, do 6178 minus 5731. $445? 447. Good. Run the rest of the list down. Go ahead. What do we get on the next one?
9.
What was it?
Negative 29.
Negative 29. Okay. Negative 30.
Oh, yeah.
Okay.
I see.
Next. Maggie, what do we get on the next one?
1450.
1450?
No.
No.
1450.
Okay. Next one. This one's going to be negative. Negative 550. 3? 513. Okay. And this last one here?
Negative 611.
Negative 611. Okay. So that's how you calculate all the residuals. The residuals are simply the difference between these numbers here. Hold it. If you did 100 minutes, hold on a second. If you did 100 minutes, would it surprise you that the surgery was $9,000? Well, I send in 100, that's $5,271 plus 1,500 is 6,700. 9,000 is way too much. Okay? All right.